Hi all. Today we'll be discussing the LeetCode problem of the day, maximum matrix sum. So you're given n cross n matrix and you have to do the following operations any number of times. Choose any two adjacent elements and multiply them with -1. So element is adjacent if they share a border. So for a particular element, its adjacent are top, bottom, left and right. Only 4 adjacent elements. The diagonals are not considered as adjacent. So your goal is to maximize the sum of the entire matrix, and you have to return the maximum sum of the matrix you can achieve after doing the operations any number of times. So in the first example, you have the matrix as such. So this is the matrix, and in this, if you take the sum of the matrix, you will get it as 0. But if you perform few operations, suppose if you pick these two elements and multiply them with a -1, then it becomes 1 minus 1, 1 minus 1. And then if you pick these two elements and do the multiplication, it becomes all ones. So for this matrix, the answer is 4 because 4 is the maximum sum you can achieve. Now for the second input, you have 1, 2, 3, minus 1, minus 2, minus 3, and again 1, 2, 3. So here we pick these two elements and we multiply with a -1. So then they both will become positive. This 2 and 3. After this, we have one single element which is negative. So if we pick these two elements and multiply, then this becomes a positive, but this becomes a negative. It becomes -2. And if we pick these two elements and do the multiplication, then in that case, this will become +1 and this will become -1. So overall, the sum remains same. So this is the maximum sum you can achieve, which is 16. So let's go the constraints. So n, it's an n cross n matrix, n cross n grid. So it is equal to the row length and the column length, and the n can be from 2 to 250, and the elements in the matrix can be from -10^5 to +10^5. Now let's go with the approach. So it is straightforward that to maximize our sum, we want to make all the elements in the matrix as positive. So suppose we have a 4x4 grid, and in this we have some negative values. So the negative, I'll represent it with a cross. So let's say this is negative here, this negative, here you have a negative. Yeah, suppose you have 6 negatives here. So the count of negatives is 6. Now to this, if you pick two adjacent elements which are negative, suppose these two, and if you multiply them with a -1, then these two elements will turn into positive. So from 6, when you multiply these two, the count of negative becomes 4. And suppose if you pick these two elements in which one is positive and one is negative, and if you do the multiplication, then what happens is one turns into positive and the other one which was positive, it turns into negative. So the count remains same. So in this case, the count is 4 only. So let's not do this. So what I mean to say is whenever we do the operations, the count of negative can either remain same or it decreases by 2, and it can increase by 2 as well. Suppose if I pick these two elements which are positive and do the multiplication, then they both will become negative. So the count again increase by 2. So the main point is the count will only increase or decrease by 2 or it remains same. So from this we can easily see that initially if the total count of the odd number negative numbers is even, then eventually we can reduce them to make it 0. So in this example, let's see how we can do that. So these two were negative, we made them positive by multiplying them, and the count decreased by 2. So the total negative count became 4. After that, we can choose these two elements and do the multiplication. So they also turn into positive. So the negative count now comes to be 2. So now we need to somehow reduce these two negative numbers also to positive. So for that, let's first bring these two numbers together. So if we pick these two elements, then this becomes positive and this becomes negative. So the negative will come here. After this, if we multiply these two, this becomes positive and this becomes negative. So that means this negative will come a bit more closer to the this other negative. So once two negatives are together, we can pick them both at the same time and do the multiplication so that both of them will turn into positive at the same time. So when we do that, the count of negative in turn returns 0. So by this observation, we can see that if the count of the negatives in the original array is even, then after doing any operations, we can turn all of them into positive. So if count is even, then you'll return the sum of the matrix. Sum of the matrix when you take absolute value of all the elements. So in this example, we can have all the elements in the matrix as negative. Suppose all the elements in matrix are negative. That means the count of negative numbers in this matrix is 16. So 16 is an even number. So we can reduce this negative number count to 0. So our answer will be sum of all the absolute value of the numbers in the matrix. Now let's look at the case where the count of the negative numbers is odd. So if count is odd, let's say this is a negative number. Yeah, suppose we have something like this. So in this case, we have 5 negative numbers. If I choose these two, I can turn them into positive. So I multiply both of them with -1 and my negative count will reduce by 2. So it becomes 3. After this, if I multiply these two, then this becomes positive and this becomes negative. Then if I multiply these two, this becomes negative and this one becomes positive. So now both are together. So I'll again pick these two, multiply with -1 so that both will turn into positive. So my negative count will become 1. Now after this, since I have only one negative number in the entire grid, no matter what, I cannot reduce this negative number to a positive number without accidentally turning other number to negative. So I can move this negative around anywhere in the matrix I pick. Suppose if I pick these two, so this negative number moves here. And once the negative number is here, if I pick these two elements, then the negative number moves here. So one thing we can see that is we can choose that where the negative number should be in the entire grid. And since we want to maximize the sum of the entire matrix, we will pick the least number and assign it as negative. That means suppose we have some values in this 4, 3, 7, 2, 8, 10, and so on, all big numbers. So that one particular negative, suppose let's say it is at -7. So we will try to move this negative to this -2 so that it will maximize our sum. So that's the approach. If the count is equal to even, count of negative numbers is even, then you'll return the entire sum of the matrix. And if count of the negative numbers is odd, then you will turn the smallest magnitude value into negative, and rest of the matrix will become positive. So for that, you can first calculate the sum of the entire matrix, and from that you can subtract this value. So initially in the sum you will have all the positive values, but since you are turning this value to negative, so from the entire sum you have to subtract this two times. So you can say -2 into 2, and this will be your output for the odd case. Now let's quickly code the approach. So first we'll use a variable count to count the number of negative numbers. So initially let's say it's 0, and also the sum. also 0. And let's take a minimum variable. Initially, let's assign it some big value. So this min will calculate the minimum absolute value among this matrix. In case that if the count is negative, then that value will be turned into negative. So now let's just iterate on the matrix. Okay, it's an n cross n matrix. So for the columns as well, I can use the same thing. So first of all, if my matrix of ij is less than 0, then I'll increase the negative count. And in the sum, I'll add math.abs matrix of ij. And once we do this, we'll also try to calculate the minimum value. So min equal to math.min of minimum comma the absolute value. Okay, so far so good. We have counted the odd numbers. We also have the absolute sum of the entire matrix, and we also have the minimum absolute value in the entire matrix. So once the loop is done, if count is even, that means we can turn the entire matrix into all positive numbers. So that is basically equal to the sum. So we can directly return sum. Now, if it is not, if it is odd, then only one element will be negative and all the remaining matrix will be positive. So that one element which should be negative will be the minimum value, so that our answer will be maximized. If we look at an example, I'll just take a 2x2 grid, so that will be easy. Let's say I have the elements as 5, 4, and then 3, 6. So far, the sum will be sum of all these elements in the matrix, which is 10, 18. Yeah. And suppose this is the matrix. So count will be, in this case, 1. And the min, let me write it all. So count will be 1. Sum will be 18. And minimum will be 3. So now in this matrix, if you want to maximize the sum, so the negative value should be assigned to the smallest absolute value, which is 3. So we pick these two elements and do the operation so that 5 will become positive and 3 will become negative. So now if you want the sum of this new matrix, so from the 18, first you have to subtract a 3. That means this is the matrix which has the sum 18. So from this, if you subtract a 3, then this becomes 0. And in this 3, if you subtract one more 3 again, then this will become a negative 3. So that means you have to subtract the minimum value 2 times from the entire sum to get the sum if the number is equal to the negative value. So at the end, you can just say return sum minus 2 into min. Yeah, that's it. Okay, let me submit. Okay, our test case is failing. Let's see. Output is this. Okay, if you see the constraints, the n is up to 250. So the n cross n, the entire grid can have up to 10 per 4 elements, and each element can be up to 10 per 5. So if you sum all the values, it will overflow the integer range. So I think the return type is also in long. So the sum, we have to take it in long. So let me just take this separately. Long sum equal to 0. Let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. For the time complexity, we are iterating on the entire matrix, which is of n cross n. So time complexity will be order of n cross n. And for the space, we are not creating any arrays, just a few variables, count, minimum, and the sum. So space complexity will be constant, which is order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.